What if I told you that one of the smallest, least flashy car companies in the world just quietly built something that has Ford engineers sweating in, Toyota executives rethinking their entire roadmap? No giant factory reveals. No Elon Musk moment. No billion-dollar Super Bowl ad. Just a small team of obsessive Japanese engineers in Hiroshima, sitting in a room, tearing apart the rulebook on combustion and building what many are now calling the most technically audacious diesel engine ever put into a mass production car. This is the story of Mazda Skyactiv D, and why the technology hidden inside it may be the most disruptive thing to happen to the internal combustion engine in the last 50 years. Stay with me, because this story is about a lot more than one engine. It's about a small company that refused to die quietly and may have just rewritten what's possible. To understand what Mazda did, you first need to understand the world it stepped into. For decades, the diesel engine was Europe's darling. The technology was invented by Rudolf Diesel in 1897, a German engineer with a vision of an engine so efficient it could run on peanut oil. Over 100 years later, European automakers had turned that seed into a global cash crop. By the early 2000s, brands like Volkswagen, BMW, Peugeot, and Mercedes were selling diesel-powered cars as the smarter, greener, more economical choice. In some European countries, more than half of all new cars sold were diesel. The pitch was simple and seductive. Diesel engines produce fewer carbon dioxide emissions than petrol. They're more thermally efficient, and they deliver that intoxicating surge of low-end torque that makes motorway driving feel effortless. Fuel economy figures that would make a hybrid blush, range that left electric cars in the dust. Ford, sensing the opportunity, invested heavily in diesel technology. The Ford EcoBlue and the venerable TDCi family became staples of the European fleet market. Toyota, traditionally a petrol and hybrid purist, also built diesel variants of its Land Cruiser and Hilux for global markets, rugged, dependable workhorses. But here's where things got complicated. In 2015, the Volkswagen emissions scandal, known as Dieselgate, blew the diesel world apart. It turned out that VW had been programming its diesel engines to detect emissions tests and temporarily clean up their act. On the road, the real-world emissions were dramatically higher. The public outrage was seismic. Diesel's reputation, built over a century, collapsed in months. Into this landscape, this ruble, Mazda walked with something extraordinary. To understand Mazda's diesel breakthrough, you need to understand Mazda's entire engineering philosophy, because it's unlike anything else in the industry. In 2010, Mazda launched its Skyactiv initiative. The name is a nod to the sky as the limit, but the real meaning runs much deeper. Skyactiv wasn't just a new engine. It was a complete reimagining of every system in the car: the engine, the transmission, the chassis, the body structure, everything. The guiding principle: take nothing for granted. Where most engineers see a compression ratio as a fixed constraint, Mazda's team saw an opportunity. The Skyactiv G gasoline engine pushed compression ratios to 14:1, the highest of any mass-produced petrol engine on Earth at the time. To put that in perspective, a standard petrol engine runs around 9:1 to 10:1. Higher compression means more energy extracted from every drop of fuel. It means better efficiency. It means more power without more displacement. But with the diesel engine, the Skyactiv D, they did something even more radical, and it went in the opposite direction. Conventional diesel wisdom said, the higher the compression ratio, the better. More compression means the air-fuel mixture ignites more. Standard diesel engines run at compression ratios of 16:1 or even 18:1. High, heavy, forceful. Mazda's engineers looked at that assumption and decided to break it. They designed the Skyactiv D with a compression ratio of just 14:1, dramatically lower than any modern diesel on the market. At first glance, it sounds like a step backward, but the results were anything but. Here's why lowering the compression ratio in a diesel is so radical and so dangerous. Diesel engines don't use spark plugs. They ignite fuel purely through heat generated by compression. The air in the cylinder is squeezed so tightly, so rapidly, that it becomes hot enough to ignite diesel fuel on its own. Pull the compression ratio down too far, and the engine simply won't start, especially in cold weather. Mazda's engineers knew this, and they solved it in ways that rivaled engineering poetry. The Skyactiv D 2.2-liter four-cylinder engine, the one powering vehicles like the CX-25 and Mazda 6, in global markets uses a combination of a two-stage turbocharging system, ultra-precise multi-stage fuel injection, and an exhaust gas system to maintain combustion reliability without needing brutal compression. The result, an engine that produces fewer nitrogen oxide emissions, one of diesel's most toxic byproducts, without relying on complex and expensive urea-based after-treatment systems that competitors depend on. Fewer parts, lower cost, cleaner burn. But here's the detail that makes automotive engineers genuinely stop and stare. The Skyactiv D became the highest-revving diesel engine ever put into mass production. Diesel engines, by their nature, are low-revving beasts. They generate immense torque at low RPM, but they run out of breath quickly at high speeds. Diesel enthusiasts know the feeling, the surge off the line, followed by a plateau. That's just physics. Or so everyone thought. Mazda's engine redlined at over 5,000 RPM. For a diesel, that's not just unusual, it's almost offensive. It changes the character of the drive entirely. It means a diesel car that doesn't just pull strongly, it breathes, it sings, it responds like a sports car. The engine earned reverence in automotive circles precisely because it did something that conventional diesel wisdom said could not be done. Now let's talk about why this matters for the giants. Ford's diesel strategy for decades was built on a simple premise: power and torque for working people. The EcoBlue diesel in the Transit and the Ranger, the older TDCi in the Focus and Mondeo, competent, reliable, but conventional. Ford's diesel engines rely on higher compression ratios and complex emission systems. They're jied, they're proven, but they didn't challenge the physics. They accepted them. Toyota built its diesel reputation on pure mechanical dependability. The 1HD and 1KD diesel engines in Land Cruisers and Hilux trucks have circled the globe, crossed deserts, survived wars. But again, they're engines built on tradition, not revolution. What Mazda did was different. Mazda challenged the assumptions underlying diesel design at the most fundamental level. And then, in what may be Mazda's most ambitious move yet, the engineers didn't stop at diesel. In 2021, Mazda introduced the Skyactiv X, a petro engine that ignites like a diesel. Using a technology called spark-controlled compression ignition, SPCCI, the Skyactiv X burns gasoline at ultra-lean fuel air mixtures under compression ignition. Just like a diesel, switching seamlessly to conventional spark ignition when needed. It runs at a 15-to-1 compression ratio. The result is a petrol engine with diesel-like efficiency and petrol-like performance. The world's first production engine to successfully pull off this combustion mode, something that had been theorized in engineering labs for decades without success. When Toyota heard about this, they sat up. Not coincidentally, Toyota later signed a strategic partnership with Mazda, taking a 5% stake in the company, gaining access to Mazda's engineering DNA in exchange for hybrid technology. That's not a coincidence. That's an acknowledgement. Mazda has also announced Skyactiv Z, a next-generation engine family set to debut around 2027, promising dramatically improved thermal efficiency and carbon monoxide emissions far below current regulations. And in May 2024, Mazda, Toyota, and Subaru announced a joint collaboration to develop engines capable of burning hydrogen and synthetic e-fuels, a direct challenge to the EV-only narrative, and a signal that combustion isn't finished yet. What makes this story genuinely fascinating is the scale of the underdog. Mazda sells roughly 1.3 to 1.5 million cars per year globally. Ford sells around 4 million. Toyota sells close to 11 million. By volume, Mazda is a rounding error in the global automotive ledger. And yet, in J.D. Power's 2025 Vehicle Dependability Study, Mazda ranked third overall in the mass market segment. Mazda ranked second behind only Buick. Toyota fell to third. Ford didn't crack the top 5. The company that everyone underestimated is now setting the standard for reliability. Built on the same engineering obsession that produced those revolutionary engines, the Skyactiv philosophy, taking nothing for granted, questioning every assumption, has filtered through the entire organization. The chassis engineers, the suspension teams, the body structure designers, all of them operate with the same relentless questioning of convention. And it shows. So where does this leave us? Diesel, as we knew it, may be dying EV. Sales are rising. Emissions regulations are tightening. Some markets have already announced end dates for internal combustion. And yes, Even Mazda, for all its combustion brilliance, is developing electric vehicles and plug-in hybrids for the future. But here's what Mazda's story teaches us, and it goes beyond cars. The most dangerous competitor isn't the biggest one. It's the one with nothing to lose and everything to prove. The one that walks into a crowded room, looks at how everyone does things, and asks, but does it have to be this way? Ford brought dependability, Toyota brought scale, Volkswagen brought ambition, and nearly destroyed diesel in the process. Mazda brought curiosity, and in engineering, curiosity taken seriously, funded properly, and executed with obsessive precision is a superpower. The Skyactiv D engine will not be the last word in this story. Skyactiv Z is coming. The Hydrogen Alliance is forming. The next chapter of Mazda's engineering saga is already being written in Hiroshima. And if history is any guide, Ford and Toyota should be paying very close attention. If you found this story fascinating, but it genuinely helps this channel more than you might think. And if you want more deep dives into the engineering battles reshaping the auto industry, subscribe and turn on notifications. There's a lot more coming. I'll see you in the next one.